3.3 Polynomial Division Factor Theorem and Remainder Theorem. Still video 3. I shut off the previous video a little sooner than I wanted because at some point, and I didn't mean to wait until this example to do it, I wanted to show you how to check your answer. How do you check your answer? Well, how do you check the answer in a number division problem? Like if you said 60 divided by 7, 7 goes into 60, maybe this isn't the best example. We'll say 61 divided by 5. 5 goes into 6 once, 1 times 5 is 5, 6 minus 5 is 1, bring down that 1. 5 goes into 11 twice, 2 times 5 is 10, 11 minus 10 is 1. And so we get 12 1/5. But how do you check the answer to a division problem? Well, you multiply your divisor times your quotient, so 5 times 12, but then you add the remainder back. And if you check, 5 times 12 plus 1 is 61. So how would we check a division problem like this? Well, if you wanted to check it, you would have to multiply your divisor, which was 2x squared plus 1, times what you claim the quotient is, which was 6x squared plus 7x minus 2, and then add the remainder back to it, so plus negative 7x plus 2, kind of running into the work over there. You would have to do a lot of distributing, but I think it's worth the time to verify that this is how you would check it. To do something bigger than a FOIL problem just requires a lot of distributing. I need to distribute the 2x squared, but I also need to distribute the positive 1. 2x squared times 6x squared is 12x to the 4th. 2x squared times positive 7x is positive 14x to the 3rd. 2x squared times negative 2 is negative 4x squared. Now distribute the plus 1. That's easy. Multiplying by 1 doesn't change anything. So positive 1 times all that is positive 6x squared plus 7x minus 2, and then add the remainder, which was negative 7x plus 2, and start gathering up all your like terms. Here's the only x to the 4th, so 12x to the 4th, I'm done with it. Here's an x cubed. It's the only x cubed, so plus 14x cubed. Now gather all the x squareds. There's a minus 4x squared and a plus 6x squared, so together that is plus 2x squared. Done with those. And if you notice, the plus 7x and minus 7x cancel, as do the negative 2 and plus 2. And that's the original dividend. So keep in mind that anytime you want to check a division problem, you can actually write this generically by representing these polynomials with functions. So if you wanted to check a division problem, in other words, if your claim is that one function f of x divided by another function g of x is equal to some quotient, which we'll call q of x, with remainder r of x, I could also write the quotient plus the remainder on top of the divisor, g of x. So we could write the answer both ways, although I prefer the fraction way. We're just saying that this is the remainder two different ways. The way that you would check this is you would multiply what you divided by, so that was g of x, times what you claim was the answer, which was the quotient. Add the remainder back to it, and you should get back the dividend. Now this is going to be important here in a little while, but I think it's something that you already know, at least on a number level, the way to check a division problem.